For horizontal asymptotes, there's 3 rules, and I'm going to give you the specific definition because you're going to have to tell me the horizontal asymptote rules in a test, and so I don't want to just be generic like I am in class all the time. So let f of x be equal, and on the top of it we're going to write out ax to the m plus dot 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 plus a sub 0. Okay? And then on the bottom, I'm going to write bx to the n plus dot 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 all the way down to b sub 0. And so what I've done is I've created a polynomial on the top and a polynomial on the bottom, where on the top, my leading coefficient is a, and I have x to the m, and then it's going to go all the way down to the constant. And on the bottom, my leading coefficient is b, x to the n, plus dot dot, it goes all the way down until you get to your constant. Okay, so here's how the rules work. So then, f of x has a horizontal asymptote when if A is bigger than B, then there is no horizontal asymptote. Okay, so if sorry, I lied. I am so sorry. If not A and B, if M is bigger than N. So if my leading coefficients, so M is bigger than N, if the top one is bigger than the bottom one, then there's no horizontal asymptote. In a class, I'll explain it as, it's kind of like if you think of this as being top heavy. If this is bigger than this, then it's top heavy. And a lot of things that if they're top heavy, will fall over and be destroyed. They'll crumble and break or whatever, and so then there is none. So there's no horizontal asymptote if it's top heavy. Okay, B, if M equals N, then the horizontal asymptote is y equals A over B. So if the if the degrees at the top and the bottom are exactly the same, then what you're going to do is you're going to take the coefficients, you're going to divide them, and that's going to be your horizontal asymptote. In C, if M is smaller than N, then y equals 0 is your horizontal asymptote. Okay, so if we look at this, if this exponent is bigger than this one, then it's bottom heavy, it's stable. And when it's stable, you always know what it's going to be. It's going to be y equals 0. Okay, so that's the horizontal asymptote rules. Now if I show you a few examples here, let's say that we have f of x equals 4x to the 5th power plus 3x squared minus 5 over 6x squared plus 2x. Okay, it doesn't really matter what it is, but what we're looking at is we're looking at these degrees, and 5 is bigger than 2, so this one has no horizontal asymptote because it's top heavy. Okay, so what if they're the same? So let's say it was 4x to the 5th plus 3x squared minus 5 over 6x to the 5th plus 2x. Okay, so now if I'm looking at this, these are exactly the same. So what I'm going to do is I'm going to take those numbers in front, and I'm going to say y equals 4 over 6, which reduces to y equals 2/3, and that's my horizontal asymptote. So that's where I would go and I would find, if I was looking here and I'd find 1 and there's 2/3, and so I'd put a dotted line across at 2/3. Okay, and then my third one, what if it was 4x to the 5th plus 3x squared minus 5 over 6x to the 7th plus 2x? Well, then I'm noticing that my exponents, this bottom exponent is bigger than the top exponent, and so I know that y equals 0 is my horizontal asymptote. And so if I look at the graph, that means the x-axis is a horizontal asymptote. And that's it.